Alright, so as we get started, I wanted to quickly review the difference between molecular compounds and ionic compounds. So when you have an ionic compound, the reason why it formed is because an ionic bond formed. Now, an ionic bond results when a metal loses electrons, so metal loses, and a nonmetal gains. Now, ionic bonds are extremely strong because you have positively charged metals being attracted to negatively charged nonmetals because opposite charges attract. Now, the other type of bond, the bond that creates molecular compounds, is called a covalent bond, and that's what you're going to learn about today. In a covalent bond, electrons are shared, and I'll show you how that works in a second. Electrons shared. Now, if we're sharing electrons, that doesn't result in an attraction, in a holding the two atoms together. So you might say, well, why do molecular compounds stay together? Why do the elements hold on? And the reason why is that the nucleus, the positively charged nucleus of each of the atoms, attracts the electrons, which pulls them together, which causes the attraction. So nucleus attracts electrons. Now, because there isn't a negatively charged and positively charged ion in a molecular compound forming a covalent bond, covalent bonds are much weaker than ionic bonds. So while ionic compounds are always solid and really hard, molecular compounds are not. Now, I'm going to walk you through 3 simple problems to show you how to create a Lewis dot diagram of a molecular compound, and it just shows the sharing. So I'm going to show you with this example, and then I'll create 2 of my own. If I'm going to create fluorine, there are going to be 2 fluorine atoms in a fluorine molecule. And so if you remember, fluorine has 7 valence electrons, so it shows 7 here and 7 here. Now remember, all of these bonds, ionic and covalent, the reason why they form is that the atoms want to have the electron configuration of a noble gas. And so this fluorine, to get the electron configuration of a noble gas, to get an octet, needs 1 more electron. But this one also needs 1 more electron. So it's not like this fluorine can give away all 7 of its electrons to this fluorine. It won't. Rather, this one says, hey, I'll share this electron with you. Okay, so I'll do a double arrow to show the sharing. And this fluorine says, well, I'll share this one with you. The reason why this works, this fluorine counts this electron and this one as its own. So if you look here, this fluorine now has 2, 4, 6, 8 valence electrons, while this fluorine has 2, 4, 6, 8. So the sharing concept is very helpful because that means that each atom can have a full octet. Now, rather than drawing 2 electrons like this, what we do in chemistry is we show that covalent bond, that sharing of electrons, with just a simple line. All right, and that's it. I'm going to show you now with water how to do this, and then with CCl4. So with water, I'm first going to draw out my atoms with their number of valence electrons. So oxygen, I'll draw here. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. Now I'm going to do hydrogen. Hydrogen only has 1 valence electron, but there are 2 of them. So I'm going to draw 1 hydrogen here with its 1 valence electron. And then I'm going to draw this hydrogen here with its 1 valence electron. Now, every single element, every single atom wants 8 valence electrons. That's the perfect octet, except for hydrogen, because hydrogen is going to assume the electron configuration of the closest noble gas, which is helium. Remember, helium only has 2 valence electrons. So this is one of the exceptions that's already coming up for this type of problem, in which hydrogen will be happy with just 2 valence electrons. And so if you see oxygen has 6 here, hydrogen wants 2, both of them want 2, oxygen wants 6, so they're going to share. Alright, so hydrogen will share this 1 electron with oxygen, oxygen will share 1 with hydrogen, okay? Hydrogen will share 1 with oxygen, oxygen will share 1 with hydrogen, and so what results is the following. There is oxygen with 2 electrons being shared between this hydrogen and that oxygen. Remember, this electron and that electron represent 1 line. Then oxygen has another covalent bond, and then you've got the rest of the electrons on oxygen. So if you notice, oxygen has this electron left, this one, and this one. It's got 4 unshared electrons. These 2 were shared, but the rest are unshared. So I'm going to draw 1, 2, 3, 4 unshared electrons. Now, a good way to check to make sure everyone's happy, all right? Hydrogen has 2 electrons because this line represents 2 electrons. That's all it wants. This hydrogen has 2 electrons. That's all it wants. Oxygen wants 8, so let's count. I've got 2 here, so that's 4. This is 6 because that represents 2 electrons. That's 8. And so this is a very happy molecular compound. Everyone's got its electron configuration of a noble gas. I'm going to do one more with you. For CCl4, carbon has 4 electrons. Valence electrons, sorry. 1, 2, 3, 4. Chlorine, I've got 4 of them, so I'll draw 4. Okay. C, L. And they've got 7 valence electrons, so I'll draw 7 here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. Now, remember, carbon wants 8 valence electrons, so does chlorine. So here's how that's going to happen. This 1 electron here is going to be shared between carbon and chlorine. This electron here from carbon is going to be shared. Okay? This electron here and that electron there, they will be shared. So carbon will give it to chlorine, chlorine will give it to carbon. Carbon will give that to chlorine, chlorine will give that to carbon. Chlorine will give it, so it's kind of repetitive. Alright, so let's think about this. Now, chlorine has these 2 electrons. So I'll represent that with a line. Chlorine with carbon, another 2 lines with chlorine and carbon sharing right here. Another line with chlorine and carbon, another line with chlorine and carbon. I'm not quite done. Okay? Notice I don't have any electrons now on carbon because this represents 2 shared electrons, 4, 6, 8. So carbon's happy because all of its electrons are being shared. For chlorine, however, it's still got these 2 here, these 2 here, and these 2 here. This is being shared, so that's now a part of the line, but those are still unshared. So I'll draw 6 around each chlorine. And let's make sure everyone's happy. Let's make sure everyone has a perfect octet. So carbon has 2, 4, 6, 8 valence electrons, so it's happy. Every chlorine has 2, 4, 6, 8 valence electrons, so they are happy as well. Alright, so for covalent compounds, it's just a matter of saying, okay, each element is going to share at least 1 valence electron. In these problems, it was just 1, which made it nice and simple. So carbon will share this one with chlorine, chlorine will share this one with carbon, and that sharing of these 2 electrons is represented just with a line. So 1 line represents just 2 valence electrons. And that's it.